Okay, everyone, today I'll be doing the 2.19 to 2.23 quiz. So first, I'll start with question 1. The current through a 50 ohm conductor is 2 amperes. The potential difference across the conductor is 100 volts. Okay, now you know the potential difference is a voltage itself, right? So we're going to apply V equals IR. You guys have to be familiar with this formula. It's very important. They'll ask you a lot about it, or you'll use it a lot. Anyway, so we're just going to substitute in our values. Our I is the current, which is 2 amperes, and our R is the resistance, which is 50 ohms. So 50 times 2 gives me 100 volts. And this is our answer for part A. Now, part B. The amount of heat liberated in this conductor in 3 minutes is 36 kilojoules. Now, heat itself is an energy, right? So you're going to use the formula E equals QV. Now, from this, you're going to have two derivations. Q equals to IT. You just know this, okay? Which means you can substitute IT back into Q, which gives me a new formula. E equals to VIT, which on a calculator is the quickest thing to do since you're not gonna have to find Q, then substitute it back in. And I will use all three of them for this question, but for the later questions, I will only use this one. So I highly advise يعني, to pay attention to all of the explanations that I'm gonna do now, so you can familiarize yourself with all of the formulas. Anyway, you guys also have to know that power is equal to IV. Okay, and even if you don't know it, يعني, let's say here, we'll compare. E equals to QV. Q is equal to IT, so we can cancel IT here. Which leaves with me, or sorry, this isn't what I want to know. Anyway, this is a derivation for something else. I'm not gonna say it. Whatever. We're gonna use now power is equal to IV. Okay. So then we're just going to substitute this back into IV here. You can see IV. So E equals to PT. These are three formulas you have to know, and they're very important. Now, when will you use each of them? So let me just erase this and make it better. VIT. When will you use these formulas? Now, you can use these two in any case, right? Because in most cases, preferably use this when they give you the charge. However, you can find the charge Q equals IT straight away, and it's very easy, right? But most of the time you should be using these two, and specifically this one, okay, since it's the quickest. Now, when would I recommend using this one? You can't use it for any case, right? Like you can use it for the same cases as these other two. However, I would only recommend using E equals PT when you have like a part that asks the power on this conductor, on the power on this resistor, whatever. If you have power in one of the parts of the questions, use this because then it's going to be really easy. Otherwise, you're just wasting time. So my best recommendation is using these two. However, I'll use all of them in solving this question now. So E equals to QV. Let's start with this one. Q equals to I times T. I is 2, so Q is equal to 2. And our time is 3 minutes, which is 180 seconds. So 2 times 180 gives me 360, and the unit for charge is coulombs. Okay, so E equals to 360 times the voltage, which is 100, just give me 36,000. Uh, what was this? Joules or kilo? Yeah, joules. Now they want it in kilojoules. So what we're gonna do, we're gonna divide by 1,000, which is as simple as removing one zero. Because remember, each zero represents a 10. So 10, 100, 1,000 leaves me with 36 kilojoules. Now again, if you don't like it this way, you can always just do it on a calculator. 36,000 divided by 1,000 gives you 36 kilojoules as well. So yeah, this is the first method. Now I'm gonna erase all of this, and we're gonna use straight away the simplest and easiest one, E equals to VIT. So we're just gonna simply plug in all our values we have. So 100 volts times uh, I is 2 times the time is 180. This gives me 36,000 joules, and the same process you divide by 1,000 gives me 36 kilojoules. It was arguably much faster solving this way than the other way. And now I will use the third method, which is E equals to PT. So E is equal to the power, which is IV, and the power is equal to 50 times, or not 50, sorry, 2 times 50, 2 times 100. 2 times 100 gives me 200 watts. Okay, so 200 times the time, which is 180. Since remember P times T, so energy is 36,000, which gives me 36 kilojoules. As you can see, they're all very similar. However, يعني these little seconds, especially in physics, matters because you might not have enough time to complete the questions. So يعني just to be safe, whatever. Okay. Now it's time for this one, which is very easy. Like this is as simple as memorizing what this means and what this means. Now, this is a rheostat. Rheostat is used to control the current. Just memorize it. This, whenever you see this bold thing, it is a rheostat. Okay, and you see XYZ or whatever 3 points and a bold rectangle, it is a rheostat straight away. A rheostat controls current, so circuit A is controlling current. Okay, now circuit B. This is a potentiometer or a potential divider. Let's call it potential divider since that's what they want. Potential divider. Now, you know a voltage is a potential difference. Now you see potential, potential. So this is obviously used to control potential difference. Another way, this is also called, by the way, a potentiometer circuit. Okay, so straight away you can get it from the name, and they only give you two options because it says that one can control current and the other one can control potential difference. So you're obviously going to choose between current and potential difference. If you read the questions, which most of you don't, يعني you're just going to read the options وهيك. But read the questions since they might give you like four options here, even though they only told you it can either control the current or the PD. So it eliminates two of the options straight away. يعني just read the questions, guys. That's all I'm trying to say. Okay, question 3 is a memorization question for the first part, thermistor. Now, my tip for the thermistor is for the first, like mostly it obeys Ohm's law. Look, because Ohm's law for the graph, for the VI graph or IV graph, whatever, is linear, perfectly linear. This isn't a linear line, but يعني it's a straight line, perfect straight line. Okay. As you can see here, it's a perfect straight line until this point here where it starts to curve, like somewhere around here. At this point here until here, it starts curving. Okay, which like straight away gives you the sign that it is a thermistor. Now, for low currents, the resistance of the circuit element is whatever. Now, as I said, it behaves like an ohmic device or a device that obeys Ohm's law for the first like short part, the first time where it's perfectly straight. And in an ohmic device, you already know it obeys Ohm's law, which is V equals IR. Okay. Now, this is purely logic. So if you have V here and you have I here, okay, what is gonna be the slope? The slope is delta V over delta I. Now, if you were to derive this to get R, you're gonna get R is equal to V over I. So what this basically means that this is R, right? This is the resistance. So the resistance, what you can get from the graph is essentially the resistance is of the circuit or the device, sorry, is the slope of the VI graph given that it obeys Ohm's law, which means it is a perfect straight line and it doesn't curve like this. Okay, so we're just going to apply this to this question. We're going to zoom in so I can get the points at a clearer image. Okay, so we have the first point. I'm going to draw it in red here. This is 0, 0. Now we also have this point here, which is 0.15. Okay, now we know our slope is equal to y2 minus y1 over x2 minus x1. This is our slope formula. You guys should already know this. So what we're gonna do, we're just gonna find the slope, which is equal to the resistance. So R is equal to V2 minus V1, R2 or X2, which is I2 minus I1. Okay. So instead of saying this, actually, yani, since we know that V is our the voltage is our Y, so 5. So our resistance is equal to the second Y point 5 minus 0 over 0 here minus or 0.1. This was 0.1 minus 0.1 0.1 minus 0. This gives me 5 over 0.1, which gives me 50. And this is 50 ohms, and this is my final answer. Perfect. Okay. Question 4. I'll just pause the recording for a short second. Okay. So now for question 4, I'm gonna take it into a separate. Can I please? Thank you. I'm gonna take it into a separate screen here. Is it still recording at 30? Yes, it is. Okay, so for question 4 now, we're just gonna solve. Simply, first of all, part A. I know there's a part D. I'll just do parts A, B, and C first. They're in parallel. So this one is 60. This one is 30. And in parallel circuits, you already know 1 over R equivalent is equal to 1 over R1 plus 1 over R2. All the way until طبعا plus 1 over Rn. Okay. So 1 over Re equals to 1 over 60 plus 1 over 30, which if you do on a calculator will give you 1 over 20. So then you flip it, Re is equal to 20 ohms. And this is part A. Now for part B, I'll just erase everything. For part B, the total resistance of the circuit is, so remember, we're just going to draw this as series now, since the resistance in series is additive, not as a fraction, as a full number, instead of drawing it mixed. So this here is going to be R12, because it's R1 plus R2, and then this here is going to be R3, and this is the end of the circuit. This is 20 ohms, this is 50 ohms. So R equivalent between these two is 50 plus 20, which is equal to 70 ohms. Perfect. Okay. Now, part C. The current passing through resistance, the resistor 3. Now, you should know in a resistor, in a series circuit, the resistance is always the same. So it stays. Yani after passing through R12, it's going to be the same as passing through R3, sorry. So what we're going to do, we're going to find the total resistance, and I mean the current, total current, sorry. This is current. My bad. We're gonna find the total current, and this is gonna be equal for the resistors 1 and 2. Not, keep in mind, not each resistor, like this current here will not be equal to this current here, whatever we find. So this I, so say here we found it is I here will not be equal to this I and this I. It will be equal to I1, so let's call this I1 and let's call this I2. It is gonna be equal to uh, the sum of them. So I1 plus I2. So keep this in mind. So we're gonna work as if it is in series. So we're gonna resolve these two, and they're not asking for this yet. So we're not gonna concern ourselves with this. I think they do in a later question, but whatever. Besides the point. Now, Vt is equal to It times Rt. Okay, so the total voltage is 14 because it's given up here, 14 volts. 14 times IT, we don't know it, and 50 plus 20, 70 times IT. So IT is equal to IT means I total, by the way, 14 over 70, which gives me 0.2 amperes. And that's part C done. Now for part D, the potential difference across resistor 3. So they want the voltage at this point here. So they want here, V3, let's say. Okay, we're gonna change. We're gonna draw back our series circuit. R1, 2, R3. So in a series circuit, the voltage is additive Okay, in a parallel circuit, the voltage is constant. So 14 volts here. What was this? This was 20 ohms, and this was 50 ohms. This comes at 0.2 amperes. Okay, so V12 plus V3 is equal to 14, or the V total. We'll just write V total and then we're going to substitute our values. Okay, now we're going to find V12. The current passing through of resistors 1 and 2, the equivalent resistors of these two, we combine them into one, basically 0.2 times 20, which gives me 4 volts. Okay, so now the total voltage is equal to 14, right? So V3 is equal to, you take V12 to the other side, V total minus V12, which equals, so V3 equals to 14 minus 4, which gives me 10 volts. This is my final answer for part D. So let's say part D here. Okay, question 5. So for question 5, what we're gonna do is the following. A voltmeter reads the maximum voltage of 10 volts. This is shunt resistance. So this is, I'll just start off by saying the formula for the shunt resistor. So V1 over R1 equals to V2 RF plus R1. Okay, now you might be asking me, what are RF, R1, V1, V2? Okay, I'll just get to this now. So V1 is this. This is the current voltage of the voltmeter, right? I'm talking about part B. Part A, I'll explain it after I do part B, because part A is really easy. And this is R1. This is the maximum at this point, at the current point. So 2 times 10 to the power of 3 ohms, because this is kilo ohms. Kilo means times 10 to the power of 3. A shunt resistance is used to modify the scale. So the new one is 50. This is V2. Okay, RF is the one you want to find. So we're going to call it X. V1 is 10 over 2 times 10 to the power of 3. We're just substituting my values into this one here. Equals to V2, which is 50, over the sum of these two. So we're going to say X plus R1, which is 2 times 10 to the power of 3. So you do this on a calculator, you will get 10 over 2 times 10 to the power of 3 equals 50 over X plus 2 times 10 to the power of 3. This gives me X to be 8,000. Now this is 8,000 ohms. Okay, they want it in kilo ohms. Again, you divide by 1,000, so X is equal to 8, oh, this is, let's just say RF equals to 8 kilo ohms. So this is for part B. Now that part B is done, part A. Okay, basically, my tip for you here is whatever is happening on the outside in the general circuit is the opposite of what's happening on the inside. So, to make this clear, let me draw a circuit for you. Let's say here we have a filament lamp, okay, or a light bulb, whatever you want to call it. Let's say this is a battery. I don't need the voltage. I don't need anything. Here is the voltmeter. Okay, now the voltmeter is in parallel with the circuit, right? A voltmeter is always in parallel with the general circuit. So on the outside, it's parallel. On the inside, it's the opposite. So it's going to be in series. The shunt resistor is going to be in series with the voltmeter. As you can see, it's on the, and the shunt resistor is on the inside. So whatever is happening on the inside is going to be on the opposite of what's happening on the outside. On the inside, it's series. On the outside, it's parallel. This also works for the ammeter, by the way. On the ammeter, so let me draw the filament lamp. Okay, here it is connected in series with the circuit. The ammeter itself is in series. So the shunt resistor inside is going to be connected in parallel with the actual ammeter. Now, the formula I just said, the V1 over R1 equals to V2 over R1 plus RF. This is for voltmeter shunt resistance. So I'll just write VSR, voltmeter shunt resistance. For the ammeter, is a totally different thing. So for the ammeter, this is the formula. The shunt resistance is equal to R or IFS. So the current of the maximum it can read at the current point. We call it I full screen because it reaches the end of the meter, right? So I full screen at the current point times the resistance of the coil, which is the current resistance. Don't memorize it as RC, as R coil. Memorize it as the resistance of the current, like the current time. When they want to modify it, IFS, the new thing plus I new, let's say, equals to the total I, the new I, right? So it's gonna be I minus IFS. Okay, this is the formula for the ammeter shunt resistor. Memorize it. It'll probably come. يعني last time they didn't bring the voltmeter one, they brought the ammeter. So either they'll bring this one or they'll bring the ammeter. Be ready for both. Okay, compare the brightness of lamps in series and parallel. This is very easy. If anything, I should skip it, but yallah. Obviously, now common sense. Here, this gets more voltage than this current here, than this light bulb here. This is receiving more current. This is receiving more of everything really than bulb 2, right? So it's obviously going to be brighter. Now, bulb 3 and 4 are connected in series. So they're going to be the same number of, they're going to be like the same brightness. Now, if you remove this, there's going to be a gap here, right? There's going to be a gap between this point and this point, meaning that current cannot flow. So no current will be conducted for part C or part B. No current if bulb number 1 is unscrewed. If you unscrew bulb 3, it will still go to bulb 2. Like if you unscrew this, nothing will go through here. So obviously this will die. However, this will still receive, this will be its own circuit and it will still receive current. So obviously bulb 1 is the most common answer, most logical answer, and it's the one that makes the most sense. This is the same concept. I will skip it. It's the same thing. Okay. The power. Now, there's another formula for power. Power is equal to I squared times R. Okay? Memorize it. It's very easy. So the power is, let's find I squared. So let's find I in general. V equals IR. Again, you should be really familiar with this formula. The voltage is 20. So let me just remove this. 20 equals to I, we want R is 5, 5I. I is equal to 4 amperes. So 4 squared times R is the resistance, which is 5. So do this on a calculator, you'll get 16 times 5, which gives you 80 watts. This is your final answer. Question 9. They're connected in parallel, these two resistors. Okay, they want the equivalent resistor. So 1 over RE equals to 1 over R1 plus 1 over R2 plus blah 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 all the way until 1 over Rn. Okay, this is just the formula. By the way, on the written part, I'm not sure you can write this, but I have a shortcut. You do this on the computer part. Re equals to 1 over 1 over R1 plus 1 over R2 plus 1 over R3. It's the exact same thing, by the way. I just moved the one, to make it, because this is how you will normally do it if you were to like simplify RE mathematically. So this is how you do it on a computer part to make it very easy. However, you guys might make the mistake where the calculator will show, like for example, 1 over R1. This will be the big one, and then 1 over R2 plus 1 over R3. No. So preferably don't do this. Only if you're really short strapped for time, and you have 2 minutes left on your computer part, you're about to run out of time, do this. And because it's risky, and you might misclick and make this the big fraction instead of this one. If you get what I mean, yani. So do, if you want, do it. If you don't want, don't. Preferably don't. Yani do it only if you're really short strapped for time. It is a shortcut after all. So 1 over Re is equal to 1 over R1 plus 1 over R2. That's R2. No, I'll just erase it. 1 over R2 plus whatever. Well, now what we're gonna do 1 over Re is equal to 1 over 30 plus 1 over 70. Remember, because they are in parallel. This will give me 1 over Re to be 1 over 30 plus 1 over 70 equals 1 over 21. Flip both sides. Re equals to 21 ohms. This is your final answer. Okay, question 10. We only have 3 questions left, Allah. If it is in series, the resistance is very easy. You just add the numbers purely. So 15 plus 20 plus 50 equals to RE. So RE is equal to 85 ohms. And these questions you should be doing in seconds. Question 11. This is amount of energy. So E equals VIT, or E equals QV, E equals PT, whatever. Uh, so, okay. Now we're just going to apply this one. Again, you also have E equals QV, E equals to, sorry, E equals to PT. You have these three. I'm not going to apply these two because I applied them in the other question and I showed you how to work with them. I'm just going to do this one, which is the easiest one. Straight away I can do it. Voltage is V equals IR. V equals to 3 times the R, which is 20. This is I, R. This equals 220 times 3, so 60 volts. Okay, now you substitute this times I, which is 3, times the time, which is 1.5 minutes, which is 1 minute 30 seconds, which is 150 seconds. Or no, not 150, sorry, that is 2.5 minutes. So this is 90 seconds. So times 90. E equals 2, 60 times 3 times 90, 16,200 joules. You divide by 10, they want it in kilojoules, so you divide by 10 to the 10,000. Shoot 10,000. 1,000, sorry. 1, 2, 3, 16.2 kilojoules, and this is your final answer. However, they took it to two significant figures, so 16 kilojoules is your final answer. Question 12. This is the graphs. You guys should memorize them. I don't really have anything to say with them. Yani, just do it. And okay, question 13, the last question. In the diagram below, the PD of the across the battery is 24 volts. So we're just gonna write down everything we have. 24, 10 ohms here and 10 ohms here. Okay, and here is 45 ohms. Okay, the current through resistor C to two decimal places is V equals IR, VT equals to IT times RT. We're gonna find the total resistance first. So we're gonna resolve this. These two are in parallel. This is gonna be 1 over 10 plus 1 over 10 equals to 2 over 10 equals to 1 over 5. So this is 1 over RE. You flip it, 5 ohms. Okay, so then 45 plus 5 gives me 50 ohms, and this is RT. This is the total resistance. So the total voltage is 24 time. No, we're not going to multiply this one. I think this is on itself. So 24 equals to 50 I total. Okay, so I total equals to 50 over 24, which is equal to 0 point, or sorry, no, 24 divided by 50. I flipped it on the other way around, didn't I? Yes. So 24 over 50 equals to 0.48 amperes. And since, what I did, I basically summarized this got resolved as RAB, and then series, what I did in the previous step. So it's for 0.48 ohms. Okay. Now, you know that, so here this is going to be flowing with a current of 0.48. Okay. So what we're going to do, remember, VT, voltage in current is in a series is additive. So V12 or VAB, sorry, plus VC. Okay, we're gonna find VC first because then VAB we're gonna substitute it in this A because remember voltage in a parallel circuit is the same. So VC equals to 45 times I, which is 0.48, equals to 45 times 0.48, 21.6. Perfect. Okay. So the total voltage is 24. So VAB equals to 24 minus 21.6 gives me 23.6, right? Yeah, two, no, sorry, two. Wait, what? Yeah, 2.4. 2.4 volts. Okay. So what now I'm gonna do? We're gonna substitute this into this. So remember that current or voltage in a parallel circuit is the same. It stays constant across A and B. So voltage AB, or the voltage of A is equal to the voltage of AB, which is also equal to the voltage of B. We don't want this. We're just gonna care about the first part. So 2.4 volts, because this is the voltage of A now, is the resistance of A, which is 10, times I, which is the current of A, divide, so IA is equal to 2.4 over 10, which gives me 0.24 amps. And this is my final answer for part B. And I already solved part A, which is here. Perfect. This is the end of the quiz, guys. Good luck. Allah, have a good day.